Alright, so we're going to go over a few more derivative examples continuing from the last video. We had a couple more rules here. Find the derivative of sine of x and cosine of x. So the derivative of sine of x is just equal to the cosine of x, and the derivative of cosine of x is equal to negative sine of x. So let's take a look at this first function. So we'll work left to right. Well, the derivative, or f prime of x, is equal to, so we have 3 sine of x here. We know that the derivative of sine of x is equal to cosine of x, so you pretty much just flip-flop these. So you'll end up getting a 3 cosine x. And then for this term here, we know that 1 over x, or negative 1 over x squared, is going to be equal to negative x to negative 2 power, because it's in the denominator of this fraction. So the exponent's negative. So from here we can go ahead and use the power rule and then put this n value, which is negative 2, and multiply by our leading coefficient, which is negative 1, and that gives us a positive 2. So that's plus 2x, and then negative 2 minus 1 is just negative 3. Minus, and since we have a lone x here, we can just get rid of this, since this rule here, derivative of just x with no power is just equal to 1, so minus 7, and that's our answer. So we'll look at the second example, working left to right again. We'll have h prime of x, and then derivative of x is going to be, once again, just 1. Now we have a negative 1/2 cosine of x here, so our derivative of cosine of x is negative sine of x. So we plug this negative sine of x back into our function. That gives us a positive 1/2 sine of x. And then 11 is a constant. We just get rid of that. And this last one down here, we have a sine function where it's just pi over 6, but if you look inside our parentheses, we have no x variable whatsoever. So what that tells us is that this is a constant. So f prime of x is just going to be equal to 0. So for sine and cosine, just remember, just keep in mind that the derivative of cosine of x is negative sine x. So just keep this sign in mind, or this negative sign in mind, when you plug it back into your function, like what we did here. We'll go over a few more interesting examples that aren't really related to sine or cosine. I just like them. So let's see. Let's say we had y is equal to ax to the third plus bx squared plus cx plus d. So if you have a function, you can, like a function like this, you can treat these a, b, c, and d values as just constants, and then from there just use our power rule and get the derivatives as usual. So let's say y prime. So looking at this first one, we know our n value is going to be 3, so we'll go ahead and just multiply it by that constant. So it'll be 3a x, and then 3 minus 1 is 2. The same thing for the second term here. Multiply it by this b constant, so it'll be 2b x, and then 2 minus 1 is just 1. So x the first, or just x. And then plus, we have a lone x again here, so that's just going to be plus c. And then d has no variable, so we just get rid of that since it's a constant. Let's go on this example here. We have g function at t. So let's say we have t radical t plus 1 over t squared times radical t minus radical 5 So if you recall from algebra, let's take a look at this first term. When you multiply two variables together, so in this case it's t to the first times t to the 1/2, you just end up adding these exponents together. So that gives you a t to the 3/2. And then for this term here, let's say we have t squared times t to the 1/2. And once again, we just add these together. And that's going to be t to the negative 5/2. And this negative sign is negative because, once again, we're in the denominator here. So, and then this radical 5 is just a constant. So we can just get rid of this thing. Now we can now that we have kind of these formatted nicely, we can find the derivatives fairly easily. So we'll have g prime t is equal. So looking at this first term here, our n value is 3/2. So I'll put that in the front. T, and 3/2 minus 1 is just 1/2. Now, since we had this negative 5/2 value as our exponent, we bring this could be our n value, we bring that to the front. So it's going to be negative 5/2 t, and then negative 5/2 minus 1 is negative 7/2. And that's going to be our final answer. So we'll go over one more example here. Say we have a y is equal to x squared plus 4x plus 3 over radical x. Now when you have a function like this, where you have a polynomial in the numerator, which is a single denominator, you can break this down using like this formula over here. So let's say we have a plus b over c. You can rewrite that as a over c plus b over c. So we'll do that for this, just to make it visually more appealing, make it easier to break this down. So we have y is equal to x squared over the square root of x plus 4x over the square root of x plus 3 over the square root of x. Now we just subtract our numerator's power by our denominator's power. So in this case, we have a power of 2 in the numerator and a 1/2 in the denominator. So 2 minus 1/2, you get a 3/2. So y is equal to x to the 3/2 power plus, and then x to the first power here minus this 1/2 power here. That gets you a positive 1/2. So you have 4x to the 1/2 power. And then since this is just the only variable in the denominator, this is just going to be 3x to the negative 1/2. Now we can have this nicely organized. We can find the derivative of this fairly simply. So we have y prime. Using our power rule, we bring this to the front here. We have 3/2x, and 3/2 minus 1 is 1/2. Plus, same thing, 1/2 times 4 is 2. 2x, and then 1/2 minus 1 is negative 1/2. And then, since this is a negative 1/2 for our n value, we multiply that by our leading coefficient, and that gives us a negative 3 over 2 x, and then negative 1/2 minus 1 is just negative 3 over 2. That's going to be our final answer. We can also write this like y prime, but we can also write it as dy over dx, which is just the derivative of y in regards to x. So, once again, just a few more simple derivative problems. Like just to reiterate, keep in mind this negative sine x when finding the derivative of cosine of x, and then plugging that back into your original function so that you have the right sign.